So if we just create a polygon cube, and again, the reason I'm doing a smooth cube rather than a sphere is that it's non-polar. It's sphere, all the points come together at the poles, but with a smoothed cube, it's equally subdivided. And so the only part where it's a little bit different are where the corners of the cube used to be. So I'm going to delete its history and freeze its transformations. And now if I want to put hair on this, I'm going to do it by, I'm going to convert it to an end cloth first. I mean, it doesn't have to be an end cloth. Let's try and do it without being an end cloth, because then we have freedom to move this thing around, right? You can always put a deformer on it to make it look like it's kind of moving. So let's just try that first. So this is when the cube itself is not dynamic, or the sphere. So I'm just selecting all the faces rather than the whole object. And I'll go to N hair, create hair. And so I want one at selected surface points. I'm going to get paint effects and NURBS curves. Only one hair per clump. And then the points per hair are the number of CVs in the curve that are created. So I've just reduced mine to 5, so it will solve a little more quickly. So create hairs. Okay, so we get that. So now I'm going to save this in case it crashes. So let's call this hairball. So now if I grab this and put on interactive playback, so now we can see it moving, right? So it works. I just need some more frames. And so right now, when I created the hair, I chose to have paint effects and NURBS curves. So here are the NURBS curves here and the paint effects. They're just right on top of each other. If we look in the outliner, because I created them as all a single hair system shape, there's just one paint effects hairbrush. And then we've got the output curves here. So these are the output curves. And then with the follicles, we have the original curve location. So the follicles are what are attached to the surface. The original hairs are attached to those. And then output curves are created, which are dynamically solved. And so Maya evaluates the difference between those initial curves, which are called the input curves or the rest curves, and then solves this thing. So if we go into the hair system shape, we've got the paint effects shape here, but in the hair system shape we can change the hair width to something high, like 5. And if I render this, that's too high. Because now it just looks like all bizarre overlapping things. So something like that. So it looks crummy because it's just the paint effects being rendered. We can convert these to polygons though. Now this, you can see the clump width scale. Now we don't have a clump, but I'm going to see if this changes the hair. No. So we have the hair width scale here. You can see they come to a point. I just open this up. So this is at the base. They're this thick, and then towards the point they come down. So we can just get rid of this one or that. Now if we render, looks different. Now there's the question, because when we convert them to polygons, they turn into triangular sort of prism shapes. I don't know where to change that actually in here, because this is different. But what we could do, I think, now let's just try this. I'll save this before I do that. If we select another paint effects brush, like this neon one again, and then if I select all of those output curves, I can then go into my generate paint effects and say under curve utilities, attach brush to curves. So now if I render it, it should be this new brush. Oh, it's got both of them now. So I could probably delete that original paint effects. Here are all the paint effect strokes that are created. There's the original one, so if I delete that. So there, now we have the new paint effects just attached to that. And I think it should just be a single brush, because I did it all at once. Let's see. Oh, maybe not. But we can select all these strokes and just tell them to use a single brush. So here are all the strokes that are created. So again, under Generate, Share One Brush. So now I can just make changes to this one brush, and it should change all of them. So I can change the brush width to make them all thicker, like that. So let's render this. This is still rendering with Maya software renderer. Okay, it's like a lightsabers. And then we can convert these to polygons. I'm going to put end caps on these though. So in the brush shape, because I don't want them just to be open-ended. So in the brush shape under mesh here, you can turn on end caps and we'll just cap them. I think, oh, it looks like it might be capping them the opposite way. I didn't plan on doing this, so I'm sure there will be problems, but oops. Well, it looks like the curves are growing out the correct direction. Okay, well, that's a problem we can deal with later, but if we select these, all of these objects, and we can convert them to polygons. So now, I don't know how well this will play back now because we've got this double layer of construction history, but if we select this thing and go back to interactive playback, okay, so now it's acting like our koosh ball, right? That's good. It's going a little hog wild, but now if we just grab something like a cube, and make this passive collider. So a passive collider is a dynamic object that doesn't respond to fields, but things can collide with it, but we can still animate it. So we can move this around. So if I go into interactive playback again, and I'm going to select this thing and turn the stickiness up. Oh, maybe I didn't. Did I not do it? Right, passive collider. Oh, it's because I made a NURBS cube by accident. So a NURBS cube can't be made into an end-cloth object. It has to be only polygons. We don't really use NURBS for that much anyway. So turn this into a passive collider. That's good. So now if we go to interactive playback mode, and I'm going to turn stickiness up on this cube. So if I go into, and I'm going to turn off gravity, just so we can see what's happening here. So now if we go to interactive playback mode and grab this cube, we can have it, let's see, they're sticking. So then the next question is, how do you render these things, right? So let's see what we can do. So if we select this thing, and let's put a new material on the base, the core. I'll just put a Mila material, and then I'll select all of these polygon objects and do the same thing. So there are loads of them. Now you might be able to combine these as a single shape and they might still react. I don't know. So if we assign existing material, that new Mila. Oh yeah, so we didn't get end caps on here, unfortunately. I'll have to figure that out. We just have to reverse those curves or something. So now if we render this, so not looking quite as good, pretty crummy. One thing you can do to try and make these things look like they're attached, I'm not sure about this, but you can use something called an MIA round corners node, and I think we talked about this a little bit before. But if I take this Mila material and do an MIA round corners, and I attach this to the bump, I think. So the out value going into the bump of this Mila material. What that does is where two objects that have the same material on them intersect with each other, it will render out a smooth transition between them here. I just don't know if these actually intersect, so that would be my next question. So let's just go in here and look. Actually, I don't even know if this is going to work at all. I know this does work, but I don't know if I've got it set up properly. So the radius, 1, bump mode. You can see it's trying there, so you can see where they do intersect, it's making a smooth transition between the two. It's just they don't intersect everywhere. So you could probably do something like select all these, I don't know, there must be a way. If I select all these faces and extrude them slightly, so keep faces together is on. Now I just don't know if I move these, if the hairs will just move too. Okay, no they didn't, but they might. Oh yeah, they jumped. Okay, so we're partway there. You just want to attach the hairs and put out your own paint effects on it, convert it to polygons. So we just have to figure out after how to close these off and hide that transition. But you can see that it's acting properly. And instead of making this an end cloth, he did, but if you want to have more control over where it actually moves, it'd be better not to turn the sphere into an end cloth, but rather just if you want to undulate around, you can put a deformer on it instead. Okay, so that gets you partway there. Maybe we can sit down later and look at it, because I don't know how to solve those last little bits yet. Speaking of deformers, though, just before we get into, actually this, I just learned this new thing. I think this was new in Maya 2015, but I'd never used it before. I'm just going to save this. There's a thing called a texture deformer. Has anybody come across this? So this is actually a really good way to sort of simulate a dynamic thing without going into dynamics. So if I just create a new scene, and let's say I want to create a plane and make it kind of warble around like it's dynamic. So you need lots of resolution for this because we're actually going to deform this thing. So I can give this sort of 64 by 64 subdivisions. So if we look in the animation menu set, we've got animate deform here. But so you can use deformers to animate something, but there are more deformers under the modeling set here. And we've looked at some of these before, using like a sine wave a wave, that kind of stuff. We've looked at lattices, a little bit at the raft deformer. But there's this new thing called a texture deformer. If we open this up, it has to have UVs. The object has to have UVs, but if you're doing just a basic primitive, that's fine, a plane or something, or you can UV map something. We can change all of these things later, so we'll just apply this. So it adds this new thing here. So let's look at this in the attribute editor. So we got this texture deformer, and here are all the settings we saw before, but now there's an input for a texture node. So if we select something like a fractal, then it's just going to deform according to the fractal, and then we get a nice procedural way of doing something like this because we can change the amplitude of the fractal and the threshold. And a fractal, for example, can be animated, as we saw last week. So I can set a key on this time after I've turned on animated. Then over 120 frames, I can turn that up a bit. I'm going to put this back onto real time. So it's just an easy way to do something like this. So obviously I've done it too fast. So I change this to 0.1. Now I've done it too slow, but you can see it moving a little bit. So again, if you want to do like a surface membrane or something like that without going to full dynamics, you can use a deformer like this to change this. And if this is too much noise, of course, because it's procedural, so it's generated by math, with your inputs in here, you can still go in here and change all of these things to get this sort of setting that you want. There are other shaders, and so other textures that you can use for something like this. So let's just map this out. So when I try and map this out right now, this fractal I know is attached to that deformer, but by default in the Hypershade, Maya doesn't want to show us non-shading and texture-related objects. But if we turn on this little button here, I don't know what it's called, but then it will actually show all other connectors, input and output connections. So these are the normal map input and output buttons over here. But over here, this will show connections to models and things like that. So you can see what's happening here. Here's our polyplane shape. Here's that texture deformer. So it's getting the fractal going into the texture attribute, and the output geometry attribute goes into the in-mesh of the plane shape. So that's how a texture is affecting a piece of geometry. In-mesh defines where the vertices are in world space. So we can get rid of this fractal. And there's this time node that's attached to this fractal because I set keys on the time, right? So this contains that. So let's get rid of this fractal. And we can use something else like an ocean shader. Sorry, texture. And we can do the same thing here. We can attach either the out alpha, no, must be the out color, to the texture here on the texture deformer. And then the output geometry is still attached to the in-mesh. So if we look here, it looks like there's nothing happening. Let's turn on wireframe on mesh here so we can see it. And it's deselected, see if there's anything going on. Nope. So if we go back into the ocean shader, sorry, texture, we can change some of these things. The texture deformer, we can turn up the strength. Oh, what are they doing here? They're doing something wrong. I'm just going to recreate this just to make sure. So So I'm just going to click in here to choose the ocean shader, or texture. Or there's water, maybe that's what I'm thinking. I can't remember. I had this working before. I've got to change something. Let's see, I thought it was scale that would turn this up. But you can attach any 2D shader or 2D texture to this. The ocean, the reason I wanted to do this is because it's got a built-in time, so you can just have this shifting over time. I'm just forgetting something simple. Can't think of what it is. No. You can try anything really. If we go to cloth, we can get something like this, which would be kind of a pain to try and model or paint on. And so in the deformer, you can change the strength, and the offset is just going to push it up or down from its origin. But again, because it's procedural, we can go in and change this and animate the cloth changing over time, and that will be played out through the deformer. And any of these attributes can be, a fractal can be animated easily because it's got a time attribute, but you could also animate any of these things here. We could just write, we could set keys on this, or we could write an expression in here. We just break a connection. If we create a new expression for this, we can say the U width equals sine time or something, just so it goes, it will oscillate with a sine wave, and be driven by time. So that's the benefit of these any of these sort of procedural node networks. They can be animated easily and changed over time. But that texture deformer is new, and it's actually quite useful. I would have used this in many cases where I turned to ncloth before, where I don't really need that much solving, where I could use a deformer instead, and this would give kind of better, more predictable results anyway. So it's just 10 after 12 now. Do you mind if we get started on expressions a little bit? Because this has come up a couple of times where we're trying to find solutions for things and we run into problems where nothing seems to work, especially with particles, using the typical means to move them around, control populations with fields and stuff like that. But then starting to look at how we can use expressions to do things maybe a little more, not easily, I wouldn't say, but do more complex things. So who's done script writing or coding here before? Some of you guys have, right? A little bit? My only experience is through Maya. So I don't know how similar or dissimilar this is to other things, but we're going to look at just a few basic things here in Maya. So before we get into particles, we'll look at an example that I was working on with Adam about cell division. Let's look at writing some simple expressions, not on particles, but on objects. Okay? So let's say I want to create a little function that automates a process for me. like, for example, creating a smoothed cube. So I do this all the time. I go in, create a cube, bless you. I change its size, and I smooth it. Going to mesh, smooth, and then I delete its history, right? So I end up with a nice smooth cube that I can use for a sphere. So one way to examine how this process works is to look in the script editor. And we can see the Mel script going on under the hood here. So here's the command to create a polycube. So this is the command here, and then these items after this with the dashes are flags, and they set certain attributes. So the width, the height, the depth, the subdivisions in X, subdivisions in Y, subdivisions in Z, the up axis here, something, and then CH is construction history, so that's turned off. So, and then the result is the creation of these two things, a P cube, which is the transformation node, and the polycube, which is the shape node. Then I scaled it sort of arbitrarily, but it did it uniformly, so it was scaled in X, Y, and Z, right? And then I executed another function called polysmooth. So, and then I did a delete history down here. So I could, if I wanted to, just turn this whole thing into a command. So if I selected all of these things and copied them and put them down here at the bottom of the script editor and paste them, I could run this again as a script. I can just delete this, select them all, select all of this, oops, and right-click and say execute. And then we start to run into some problems because there's nothing named P cube here yet. Oh, it's because I grabbed it on. I didn't grab all of it. Let's select all this again. Okay, so it runs that, right? So now if I just grab this and move it off to the side, if I want to run it again, I can do that. But it didn't work. It worked the first time, but not the second time. Anybody imagine why it's not working properly? Yeah?
Because you already have a polycube one.
Right. So yeah, exactly. So we ran it the first time, and then this polysmooth, if we look at it here in our script, is applied to the argument. So you've got a command, you've got arguments, and this is the argument here, polycube1, and then these flags. So when I ran this again, it just ran it and applied the smooth again to this. It created a new cube, but this is called polycube2. So when I did the smooth, it applied it to the wrong thing. So let's look at how we can do this a little bit better. So before we do that, we have to talk a little bit about variables in Maya, in Mel. Sorry, just a sec. Let me find this thing. Too many windows. We'll take a break in 15 minutes for lunch, so don't worry. So typically when you write an expression in Maya, it follows these three steps. You create some variables. We'll talk about the different variable types. You set the variables, and then you assign values to attribute variables. So the different types of variables we're dealing with here. So a variable is something, if you see it in a script, would be something like this. $, and then some arbitrary text. And a variable is just a way to hold information. It's a container for data that you can put in there. You have to declare what kind of variable this is. So this I'm going to use to store position data, for example. And so position data in Maya is x, y, and z in space, right? And so there are a number of different types of variables. One is a vector, and this contains 3 values, like x, y, z, RGB, that sort of stuff. We've got an integer, and this is a whole number. We have float. It's a number with a fraction. So 1.5, 1.67 is a float rather than an integer, which would just be 1 or 2. And then a string. And that's a list of characters. So like names of things. And any of these things, if you want them to contain more than a single value, like a vector will always have 3 values, x, y, and z. But if you want to have 5 different x, y, z values, then you have to make it into an array. An array is defined by naming a variable like this. POS, open and close square brackets. Just to indicate that it's a container for more information. So let's look at this example of the creating the polycube, right? Sorry, I'm going to turn on word wrap here. So what we have to do with this function is, again, still just do the polycube function. It's going to create a polycube. And then we're going to do another action here. And this is called, we're going to create a variable, and it's called $SEL. And so what is $SEL? So I've declared this as a string variable, so it is something that contains the names of things. And I've declared that it's an array, so it can contain a whole bunch of things if I wanted to. And then I have it equaling something, so I'm giving it a value. And this command, ls, is list objects, and then this flag -sl is selected. So this is asking Maya to list the things that are selected in the scene. And these 2 tick marks here, whenever you have a command and you want to gather the results of that command, you put them inside these tick marks, which are the same key as your tilde key on the screen or on your keyboard. So now when we run this command, if we say we create a polycube, and then it will be selected on screen, and so we're asking Maya to find out what is in that selection, so fill $selection with a list of selected objects, it'll just be 1. And then we run the polysmooth on it. But instead of saying polycube1 at the end here, we put that variable in there. So whatever is contained by that variable will now have this function put onto it. So if we copy all of this stuff, and go back into here, Now if we run this, let's see if it works. So if we execute this command, we get a little smooth cube. Now if we execute it again, we get another one. And so it's applying it to the selected object. So now if I wanted to change this, like if I want this to have more subdivisions in the smooth, I can go into my script and find out where that is. So that's listed under the flag DV for divisions. So right now it's just got 1. I change that to 3. I can run this again. Now I've got a smoother cube. If I want to save this, I can just middle mouse drag this up to my shelf, and that'll create a button for me to do this kind of thing. So I delete all these things and just create a new smooth cube here. If I want to name this thing, because right now it's just called polycube, I can put a new flag in here. -N is to add a name, and I can call it me, my name. And if I run this again, then we have a new shape. So I just wanted to introduce this idea of different types of variables. What we're going to do, we'll take a break. I want to spend a little time after lunch just showing you a more complex setup to use this with particles to do something, to control a population of particles, to do something like cell division. And the last thing I'll say before we take a break, because I've been going on for a long time, is that the best book for something like this was written a long time ago. It's called Mel Scripting for Maya Animators. So I still use this as reference. It was written originally, I think, 2002. So some of the particle stuff is out of date because they never refer to end particles, but all the command references are still good. But this is available for free at U of T. You can just download it or view it online, but you can download the PDF. So if you just do a search for Mel Scripting for Maya Animators, will eventually come up. Yeah, so when that comes up as the title, you can connect to this resource, and it's a digital book. And then if you're logged in to the library system, you can just read online, or you can download the PDFs to save for later. So all the basics of Mel commands are here. It's a very easy reading book, and if you are doing any kind of script writing, it's worth taking a look at and working through a couple of the exercises. But when we come back after lunch, we'll go through one exercise together of building a populations of cells that can divide at certain locations in space. And I'll try not to go on too long about that so I can give some help for you. This week, I'm going to be around Wednesday after I finish teaching in the morning, so if you need help. And then I'm going to come in on Thursday, too, so I'll be here on Thursday, at least for the morning. So any questions before we take a break for lunch? We'll look at expressions a little more closely. I just gave really brief overview, but you'll see by when we create the next one that you'll get a better idea of how it works. Okay.